Humanity has always been obsessed with pushing the limits of science. But some experiments crossed lines so dangerous, so unpredictable, that they nearly triggered global catastrophe. From nuclear nightmares, to biological accidents, to scientific tests that should never be repeated. This is the most dangerous experiments humans ever attempted. Explained. In the heart of World War II, a clandestine race against time was underway. The Manhattan Project, America's top-secret endeavor, brought together the world's sharpest minds with a single, terrifying goal: to build an atomic bomb before Nazi Germany could. The stakes were absolute. Failure meant the potential for a world living under the shadow of a fascist nuclear power. Success, however, meant unleashing a force of unprecedented destruction. The weight of this decision rested heavily on the project's scientific director, J. Robert Oppenheimer, and his team. They were venturing into a realm of physics that was almost entirely theoretical, and the final proof of their work would have to be a full-scale detonation. On July 16, 1945, in the remote Jornada del Muerto desert of New Mexico, that moment arrived. At 5:29 a.m., scientists detonated the world's first nuclear bomb, codenamed Trinity. In the seconds leading up to the test, no one knew exactly what would happen. The uncertainties were so profound that some physicists, including the brilliant Enrico Fermi, harbored a chilling fear that the chain reaction might not stop. They theorized it was a remote possibility the explosion could ignite the nitrogen in Earth's atmosphere, setting the entire planet ablaze and ending all life instantly. The result was not global annihilation, but it was biblical in its scale. A blinding flash of light, brighter than 1,000 suns, turned night into day. A colossal mushroom cloud of superheated dust and radioactive particles surged 7 miles into the stratosphere. The shock wave, a physical manifestation of the atom's power, was felt over 160 kilometers away, rattling windows and shaking the earth like a profound man-made earthquake. In the aftermath, Oppenheimer famously recalled a line from Hindu scripture: "Now I am become death, the destroyer of worlds." The Trinity test was a success, but it was a somber one. It marked the violent birth of the atomic age, proving that humanity now possessed the most powerful and terrifying weapon ever created. This single event irrevocably altered the course of history, ushering in the Cold War and a global arms race that held the world hostage for decades. The experiment's legacy is also etched into the very ground where it happened. The blast fused the desert sand into a glassy, radioactive green mineral now known as trinitite. Even today, nearly 80 years later, the ground at the Trinity site remains radioactive, a permanent physical scar reminding us of the moment we first unlocked the terrifying power of the atom. In the chilling calculus of the Cold War, the greatest fear was a decapitation strike. A surprise nuclear attack so devastating it would wipe out a nation's leadership before they could ever order a response. The Soviet Union, haunted by this possibility, engineered a solution of terrifying ingenuity. They built a secret, semi-automated system officially known as Perimeter. To the West, it became known by a more sinister name: Dead Hand. The concept was born from the logic of deterrence, but taken to its absolute extreme. If the USSR was annihilated and its command structure silenced, Dead Hand would ensure the aggressor did not survive. It was designed to be the ultimate insurance policy, a doomsday machine that would automatically launch a full-scale retaliatory strike. The most chilling part? It was designed to function without any human intervention in its final, world-ending phase. A computer could end the world. The system relied on a complex network of sensors to determine if the motherland had been struck. These weren't simple tripwires. They were designed to paint a complete picture of Armageddon. Seismic sensors would listen for the telltale ground-shaking signatures of multiple nuclear detonations. Light and radiation sensors would scan for the blinding flashes and radioactive fallout that accompany a nuclear attack. Atmospheric pressure sensors would detect the overpressure waves from explosions. But the most critical component was communication. The system would constantly monitor secure military radio frequencies. If it detected a nuclear event, and communication with the general staff in Moscow went silent, Dead Hand would initiate its sequence. This is where the automation became truly terrifying. The system wouldn't launch the entire arsenal directly. Instead, it would transfer launch authority to a handful of junior officers in deep, hardened bunkers, who would then make the final decision. However, if even they were unreachable, the system had a final, fully automated protocol. It would launch special command missiles. These rockets, armed not with warheads but with powerful radio transmitters, would fly across the Soviet Union, broadcasting launch orders directly to every remaining silo and submarine. Every missile still in its silo would fire. Every submarine still at sea would unleash its payload. It was a guaranteed catastrophic response, triggered by an algorithm. The logic of deterrence demanded that your enemy believe you would always strike back. But what if the system failed? What if a massive earthquake and a communications blackout were misinterpreted as an attack? The line between ensuring peace through fear and causing accidental extinction was terrifyingly thin. It was humanity's closest step to a real-life doomsday device. And while the Cold War may be over, some reports suggest that a modernized version of the perimeter system remains active in Russia today. A silent, automated guardian still waiting for a signal that must never come. From 1932 to 1972, the U.S. Public Health Service conducted one of the most unethical experiments in medical history. Hundreds of African American men with syphilis were intentionally left untreated, even after a cure became available. Doctors watched the disease destroy their bodies, simply to observe its progression. This experiment caused blindness, insanity, death, and generational trauma. It sparked global outrage and permanently changed medical ethics. In the 1950s and 60s, the CIA ran a top-secret program called MK Ultra. The goal? To develop methods of mind control using LSD hypnosis, sensory deprivation, psychological torture. Many subjects had no idea they were being experimented on. The project remains highly classified and thousands of documents were destroyed. To this day, no one knows the full scope of what happened, or whether similar programs continued in secret. Deep beneath the serene countryside on the Franco-Swiss border lies the largest, most complex machine ever built by humankind, the Large Hadron Collider at CERN. A 27-kilometer ring of superconducting magnets designed for one purpose: to smash particles together at nearly the speed of light, recreating the conditions that existed a fraction of a second after the Big Bang. It is a monument to human curiosity and ingenuity. But as the day of its first activation approached in 2008, a shadow of profound fear fell over this monumental achievement. A number of critics, including some physicists, raised a terrifying possibility. They argued that the immense energy concentrations created by the collisions could, theoretically, spawn microscopic black holes right here on Earth. The public imagination ignited with apocalyptic scenarios. If one of these miniature black holes were stable, it could begin to accrete matter, pulling in everything around it. It would be an unstoppable, infinitesimal seed of destruction, hypothetically growing and consuming our entire planet from the inside out. CERN scientists moved to quell the growing panic, publishing extensive safety reports. Their primary counterargument rested on a theory from Stephen Hawking himself: Hawking radiation. They explained that any such micro-black hole would be so hot and unstable that it would evaporate in a fraction of a second, long before it could pose any threat. They also pointed out that Earth is constantly bombarded by cosmic rays with far greater energies than the LHC could ever produce, and yet the planet remains intact. But these assurances did little to calm the most profound fears. Lawsuits were filed in an attempt to halt the experiment. The core of the anxiety was the word theory. While the scientific consensus was overwhelming, it was still based on theoretical physics that had never been tested under these exact conditions. That was, after all, the entire point of the collider, to push physics into unknown territory. What if the calculations about Hawking radiation were incomplete? What if there was some unknown stabilizing factor at these unprecedented energy levels? Safety wasn't just assured, it was predicted. And there's a world of difference between the two. Although no Earth-swallowing disaster occurred, the experiment highlights a fundamental tension in the pursuit of knowledge. The LHC continues to operate, pushing the boundaries of what we know. It remains one of the most ambitious, and to some, one of the most controversial scientific instruments ever conceived. A machine built to probe the very fabric of reality, whatever the perceived risks. Gain-of-function research involves taking dangerous viruses and making them even more infectious in a lab. Scientists do this to understand how future pandemics might evolve. But the risks are extreme. Several times, highly contagious viruses have accidentally escaped labs. Smallpox, SARS, H1N1. Each incident could have triggered global catastrophe. Many experts argue this research is too dangerous to continue. Yet it still happens today in labs around the world. In 1984, Australian scientist Barry Marshall had a theory that stomach ulcers were caused by bacteria, not stress. No one believed him. So he did something shocking. He drank a beaker of bacteria to infect himself. He became violently ill, proving his theory and winning a Nobel Prize. But the experiment was incredibly dangerous. He risked permanent organ damage or death. It remains one of the most extreme self-experiments in medical history. Science advances when humans take risks. But sometimes the risks become unimaginable. From nuclear fire, to mind control, to viruses engineered in labs. These experiments remind us how easily curiosity can cross into chaos. If you enjoyed this documentary, hit like, subscribe, and comment. Which experiment shocked you the most?